This is lesson 3B, guys. So we're starting on page 21 of your packet. Okay, we've already done 3A. We did exercises 1 and 2. We're actually going to start with exercise 4 and then work backwards because exercise 4 really introduces this lesson. And today we're basically going to learn about how to write an exponential function when we have 2 points, okay? And one of the points is not the y-intercept, right? We don't have the 0, point, and the x values are not consecutive, okay? They're not one number right after the other, okay? So basically, it says by substituting the 2 points into a general form of an exponential, we're going to create a system of equations. Okay, so we have the 2 coordinates, right? We have 236, which is an xy pair. Okay, these are xy pairs. And we also have 5, 121.5, or 121 and a half. All right, so it says to substitute these in and create a system of equations. All right, as a general rule, to make this easier, I'm going to put the higher numbers on top. Instead of y, I'm going to, well, let me write the general form first. Okay, instead of y, I'm going to substitute with the y values. So my first equation with the higher numbers, to make my life easier, it really doesn't matter, but it is easier. I'm going to just substitute my y's in my corresponding x's. So here's one substitution with the y and the x substituted. And then my other substitution is going to look like this. 36 equals a, b, and now the x is 2. All right. So if I'm solving these equations, basically it said to divide these 2 equations to eliminate a. All right. So since typically, or technically, this is an equation. So 36 is equal to AB squared. So what I'm going to do is I'm going to divide both parts of this equation by these equals to get one new equation that will cancel out the a's. And you'll see how this works again. So I'm just going to rewrite what I just did. Okay, I just substituted so far. And I'm going to divide here. All right, and the reason why I want my bigger numbers on top is because when I'm dividing, okay, it's nice to divide. These are just numbers, so I'm going to divide these to get a value. The a's will cancel out, and when I divide, I subtract exponents, okay? So let's see, I did this earlier, and when I divide 121.5 divided by 36, I get 3.375. And remember, when I have the same base, I'm going to subtract these exponents. And this gives me b to the third. Okay, so this says for part C, solve the resulting equation for the base b. All right, so basically, I could continue up here, but I have 3.375 equals b cubed. Now, to undo a b cubed, I can either take the cubed root of each side, okay, or I can raise both sides to the 1/3 power, which is the same as taking the cubed root. All right, so I'm going to take the cubed root of 3.375, and I'm going to show you on Desmos here. This doesn't take too long. I should have pulled it up already. I apologize for that. Desmos. And change it to a scientific calculator. And for cubed root, I'm going to pick this little guy right here with the n, and I can put a little 3 in there for a cubed root, and I'm going to do 3.375, and I'm going to hit enter, and 1.5, you can see the answer right there, 1.5 is what I get. All right, so I'm going to minimize that, and my b value is 1.5. All right, so now I need to determine the value of a. Well, my general form of my exponential is y equals ab to the x. I can choose an xy value to use, because in order to solve for a, I need to have all of the rest of the variables substituted. To solve for a, I need to have an xy and a b. So I'm going to use obviously the b value is 1.5. We just calculated that. And I'm going to use the x value of 2 with the y value of 36, because it's a little easier to use than the other coordinate 5, 121.5. And this is similar to what we did in 3a now. We have all of the other variables. We need to solve for a now. So I'm going to just substitute 36 equals a times 1.5, the x's squared. All right, so now I can do the 1.5 squared, and when I calculate this, okay, it's kind of like 15 squared is 225, so this would be 2.25 times a. I'm going to put the a after it because that's how I typically write it. And to solve for a, I can just divide by 2.25. And I already calculated this ahead of time, and a turns out to be 16. Okay, so after I determine a, okay, I have the b, so now I can determine my final equation, which is y equals, the a goes first, 16, that's my initial value. The growth factor would be 1.5, and I leave x as x. Okay, so that's all there is to it. We set up a system of equations, we divide, solve for b, and then we solve for a. All right, I'm going to go up to exercise 3. Okay, this is the same thing. We have two non-consecutive x's. We do not have a y-intercept, so we're going to make a system of equations and divide. And this one only wants the value of the base or the b value. So remember, this is function notation. Basically, this is giving me the coordinate 4, 3. When the input is 4, the output is 3. And this gives me the ordered pair 6, 48. When I substitute, I like to put the higher numbers on top. So the y value is 48 equals ab to the 6. And for the second one, which I'm going to divide, my y value is 3 equals ab to the 4th. And I can just simply divide these. When I divide, the whole purpose is to get the a to cancel out. 48 divided by 3 is 16. Remember, I subtract exponents, so 6 minus 4 is 2, and then I can take the square root, or I'm just going to show you here, instead of taking the square root, you can take the 1/2 power, okay? 2 times 1/2, the power to a power, we multiply exponents, so this would give me b to the 1st, or just b, and 16 to the 1/2 power is the same thing as the square root of 16, so this would give me a b value of 4. All right. Hopefully I am going fast, but remember, you can slow down the video or pause it at any time. So basically, if we have non-consecutive x's without a y-intercept, you just set up a system of equations. All right, we're going to skip exercises 5 and 6. We're actually going to do this on Wednesday. We already did that one. Okay, so for number 3 here, I'm going to do one of these with you, and the other one will be homework, and I will do the harder one with you. So 3B is a little more difficult than A. So A is going to be part of your homework. You'll have 3 problems to do on your own for homework. All right, so basically same thing, right? This is just more of the same. We have our general equation, y equals ab to the x. We have no y-intercept given, and these are non-consecutive x's. So I'm going to substitute first with the higher numbers on top because it makes my life easier. Okay, if you don't do the higher numbers on top, it'll still work out. It's just the calculations will be a little bit more difficult. We'll end up with negative exponents, and that's no fun. All right, so I substituted my x and y in for my first equation, and I'm going to divide it by this 192 equals ab to the 1st. And for this one, I said the higher numbers on top. I like to use the higher exponents. I should have specified here. Okay, it's okay to get a fraction that's a proper fraction. So when I divide these, actually, on my notes, I did use the negative exponent, but I can just pull up Desmos and I'm going to see what happens when I divide these. So 192 divided by 60.75. Enter. And, oh, this gives me it looks like a fraction that's not very pretty. It looks irrational. It should be rational because it's a fraction. So I'm just going to leave it as this value. Okay, I'm just going to work with this fraction then because my decimal didn't come out pretty and it doesn't tell me to round. So to get my exact answer, I want to leave it like this. All right, when I subtract exponents, I get b to the 4th power. All right, so I could take the 4th root, or I can take each side to the 1/4 power. And I'm going to solve for my b. So I'm going to go back to my Desmos, and I'm going to raise this value to the 1/4 power. Okay, so I think I can just do this maybe. Let's do it again. Okay, 192 divided by 60.75, and I'm going to make sure the whole thing's in parentheses, and I'm going to raise it to the 1/4 power. Enter. Okay, and this gives me 1.3 repeating. Well, I know 1.3 repeating is equal to 1 1/3. And I want to write it as an improper fraction, so I'm going to write it as 4/3. Okay, so b equals 4/3. Okay. And I would have to solve for my a value. Okay. All right, so something's wrong here, because I see that as I'm getting higher x's, my y values are decreasing, so my b value should be less than 1. So I need to find out where I made my mistake. I put in 60, a, b to the 5th, 192. Oh, I think when I put it in the calculator, I put it in the opposite way. I did. Okay, so I'm just going to change this to the reciprocal. I could just take it to the -1 power. 60.75 divided by 192. All right, so that gives me that number. And then I'm going to take that same number to the so if I just make this a -1/4, it'll fix my answer. So I'm going to just put a negative in front of that and put enter, and my b value becomes 0.75. So I'll fix that. That makes more sense. Okay, so this is the only value that's incorrect, and I get 0.75. So it's nice to make sense of your answer and make sure that you're on the right track. Like I said, I knew that my values were decreasing as my x increasing, so I knew my b value had to be less than 1, and it kind of flagged a mistake for me. All right, so now that I have my b value, I can substitute any xy pair. I'm going to choose this one because it's a little nicer to work with, no decimals. And I get 192 equals a times 0.75 to the first power. It's kind of nice when you're substituting with the first power, because that's the same thing as just 192 equals 0.75 times a. And then I can divide both sides by 0.75 to solve for a. And 192 divided by 0.75 is 256. Okay, so now I can write my equation. Y equals 256 times 0.75, and then my x goes back to x. So I have a general form that works for all xy pairs. And just to show you, it only takes a second to check these. Okay, so I'm going to go to the graphing for Desmos. It's a little slow today, but here we go. Okay, so type in my equation that I think is the answer. 256 times 0.75, or you can put in 3/4, same thing, and raise it to the x power, and enter. Okay, I'm not going to be able to see it because the y-intercept is 256. There it is. I can go to my settings and go to the table. Okay, so if I want to see if these points are on there, 192. Okay, there it is, 192. And for 5, I can just type a 5 here, and it gives me my 60.75. And I just confirm that those 2 points are on my equation, so I know that I'm correct. All right, moving right along. So we're going to skip this page, the rest of this page, and we're going to talk about number 7. Okay, number 7, if you had class for 3A, I actually did this with you. So the work's already done. I'm just going to kind of talk you through it. All right, so this, before I give you too much information, it talks about a goldfish population, and they're giving us 2 coordinates basically. In 2002, we had 380 goldfish. In 2006, the population grew to 517. Okay, it tells us that y is the population and x is the number since 2000. All right, so basically they're giving us 2 coordinates. This has been 2 years since 2000. All right, so our x value would be 2. And notice for part A, I set up the table, so you're going to want to pause the video and copy this. Okay, the x value is years since 2000, and the y value is the population. So it's nice to kind of label your x and y values so you can understand what they are. So basically, they're giving me 2 coordinates. Okay, I have x1, y1, and x2, y2. And you'll see in the next part why I labeled them x1, y1, and x2, y2. Okay, so for part B, it says determine a linear function. Okay, if they give us 2 points, we can make different types of functions through those 2 values. So they're asking us linear, so we start with y equals mx plus b. And for a linear, instead of solving for a and b, we need to find the m and the b. All right, so m is just simply the slope, and hopefully you remember this from Algebra 1, that you just do the change in y over change in x, or y2 minus y1 over x2 minus x1. So that's where we got these values, and we substituted, and this reduces to 137/4. Okay, 137/4, or you can write it, if you prefer, as the decimal 34.25. And 34.25 is the slope. So basically, change in population for every year. Okay, so this represents about how many goldfish approximately, right? We're not going to have a quarter of a goldfish, but with this linear model, they gained about 34 goldfish each year. All right, so we have our m value, and then to solve for b, we just simply substitute an either xy pair. Okay, this 380 looked easier, so y is 380. You can use it in fraction form, or we could have substituted the decimal in for slope when the x value is 2 and we had to solve for b. Okay, so I'm going to kind of, this was the calculation for the linear, which I just boxed off. This green is the exponential, okay, so we don't want to go by that. We just substituted and found the b value here. Oops, I made my box a little too short. So this is the linear equation we end up with. Okay, I left this one in fraction form, so this is my linear equation, and y equals mx plus b. All right, so part C asked for the exponential. Okay, so just to be clear, I'm gonna highlight. This is all the linear stuff that we did. Okay, this is part B is all the linear. Okay, that's linear. Solve for slope, substituted, found the y-intercept. All right, B asked for the exponential. Okay, so we have our two coordinates. We substitute them into the formula. We divided, subtracted exponents, took the 4th root, and found our growth factor. And we said 1.08. Okay, this is a growth factor of 8%. So this is the same as 1 plus 0.08, which is 8%. So the fish were growing about 8% each year. That's my growth factor. So we just simply substitute in the growth factor with one of our easier coordinates, and we picked the 380, and we solve for our a value, which is 325.8. Okay, so this is our exponential function. Okay, our exponential function looks different. So this gives us an initial value of 325.8. Okay, we started with this amount in 2000 at the initial year, and it was growing by 8%. Whereas the linear started out with 311, 1.5 fish, approximately 312 fish, and grew 34 fish each year. So it says, which one predicts a larger population in the year 2000? Well, that was the initial population. Okay, so the exponential with 326 approximately, right? This would round to 326, was higher than the linear, which is about 312. Okay, so 326 was greater than the 312. All right, so just this example basically tells us if they give us two coordinates, there's more than one function that we could create. With population, we tend to use exponential. Okay, population grows exponentially usually, but they had us do the linear as well just to compare. Okay, number 8, we are going to skip. And that brings us to the last part of the lesson. 9 and 10 we did in 3A. Number 11 is going to be homework, which you can come back and do in a minute. And number 13, I'm going to do with you. And number 14 is going to be homework. So like I said, you have 3 problems for homework. You have to go back and do the part A of number 3, and then you have to do questions 11 and 14, and I will finish 13 with you. Okay, 13 is a little bit different because we have this negative exponent. Okay, so we have our 2 coordinates, and it's asking us for the exponential for all of these, and we can see it kind of looks like a J curve, right? We should expect it might be exponential. It's definitely not linear. So I'm going to start by using my general form of my exponential, y equals ab to the x, and I'm going to substitute my numbers in. And I'm going to put the highest exponent on top for this one. All right, so I'm going to substitute 10 thirds for my y, right? I have my x and my y. This is my x and my y. So I have 10 thirds equals a times my b value, which is unknown, to the first power. And then for the second one, I have 45 fourths equals ab to the negative second. All right, and the reason why we do this is because we can cancel out the a's when we're dividing, canceling out common factors. And for the numbers, we simply divide like we always do. So we're going to divide 10 thirds divided by 45 fourths. Okay, so 10 thirds divided by 45 fourths. I'm just going to put it in Desmos. I'm going to go back to the scientific here. 10 thirds divided by 45 fourths. Okay, so 10 thirds, okay, divided by, and then I'm going to go ahead and do this just to make sure it's accurate. I want it to look just like I have it on my paper, 10 thirds divided by 45 fourths. And this gives us 296, 296, 296. So it's 296 repeating. All right, so I am going to leave it. Actually, you know what? To work with it a little bit differently, when we divide fractions, 10 thirds, okay, divided by 45 fourths is the same thing as 10 thirds times 4/45, right? Keep, change, flip. That's what I'm doing. I'm keeping this one. I'm changing it to multiplication. I'm flipping this one. So if I want to write it as a single fraction instead of a quotient of fractions, this is going to give me 40 over 135. So 10 times 4 is 40 over 3 times 45 is 135. So I'm going to use this instead of this, okay? So 40 over 135 equals b, and remember I subtract exponents, so be careful here. This is really 1 minus a negative 2. Okay, so my new equation, okay, this is just the work for that, is 40 1/35 equals b. 1 minus a negative 2 would be b to the third. Okay, and again, I can take the cubed root of this to solve for b, or I can just raise it to the 1/3 power. It's the same thing. Okay. And it really doesn't matter. I think it's easier to do the 1/3 power, which is the same as the cube root, just in a different form. So I'm going to do 40 over 135 to the 1/3 power, and I'm going to use Desmos again. Okay, so 40 divided by 135, and get out of here. And I'm going to raise it to the 1/3 power. Okay, and actually it comes out kind of nice. 0.6 repeating. Okay, hopefully you know that is equal to the fraction 2/3. Okay, another thing, if you didn't recognize that 0.6 repeating is 2/3, if you take if you reduce 40 over 135, I'll show you. Might want to reduce the fraction first. Okay. Let me have that. Oh, it just gives me that same one. On the inspires, it actually reduces to 8/27ths, and then you can recognize each one as a cubed root. So hopefully you recognize that 0.6 repeating as a repeating decimal is 2/3. All right, so now once we have b, we can just substitute, like I said, any of our pairs. I'm going to use the 1, 10/3 as my xy. So I have 10/3 equals a times b, which I know now is 2/3, to the x power, which is 1. And 2/3 to the 1 power is just 2/3. So I just simply have to divide both sides by 2/3 here. And you can calculate this, but 10/3 divided by 2/3, if I multiply both of these by 3, cancels out the thirds. It's the same thing as 10 divided by 2, which is 5. So my a value just turns out to be 5. And your a and b values will come out to be, for this homework, you shouldn't have to round. You'll get fractions like I've been getting, okay, or they'll come out to nice integers, okay, whether they be negative or positive. All right, and I'm just going to finish this with checking this because it, like I said, it only takes a little bit of time to check. Okay, I'm just going to go back to the graphing calculator so I can actually graph this and check the table. All right, so I'm going to put in my y equals, it was 5 to the 2/3 power, and raise it, shift 6 to the x, and I see my exponential, okay, and I'm going to go to settings, and I'm going to go to table, and 1 was 10/3, which is the same as 3 1/3. Okay, so here this is the same as 1, and this is 3 1/3, which is 3.3 repeating. So that's a check. And my other coordinate I need to check was my -245 Okay, so -245. And just to change this into a decimal first, 4 goes into 45 11 times with 1 left over, so 11 1/4, or that's the same as -2 11.25. So this is what I'll see on Desmos, -2 11.25, if I'm correct. So -2 11.25, it's right there. So all is good. I know my equations are correct. So please, you have 3 problems to do. Please check your answers to make sure that you're doing this correctly, and you know where to find me for help. All right, have fun. Out of here.